Hello there, and welcome to the Sleepy Scholar. Tonight's journey takes us across the quiet world of islands, where lonely beaches, hidden forests, coral lagoons, seabird cliffs, old settlements, and distant volcanoes all become part of one calm story. Along the way, you will learn how islands shelter unusual life, shape human journeys, and hold small worlds apart from the mainland. If you enjoy these quiet explorations, consider subscribing so you can easily return here whenever you need to rest. For now, get comfortable. Let your eyes grow heavy. Let's begin. Because water draws a clear boundary around them, islands often feel like complete little worlds. A mainland landscape can stretch without an obvious edge, but an island has a clear outline. Whether it is a mountain in the sea or a low green shape in a lake, this boundary changes how people and animals move. It can slow the arrival of predators, limit the spread of plants, and make travel depend on boats, winds, currents, bridges, or tides. It can also make the weather feel more present, because the open water around the island helps shape breezes, mist, and clouds. Even when an island is close to a larger coast, the surrounding water gives it a separate rhythm. The shore becomes both doorway and border. That is why islands often feel easy to imagine as whole places, held gently inside their own ring of water. From the shore to the highest ground, many islands create clear zones of life. Near the coast, plants must handle salt spray, wind, shifting sand, or rocky ledges. Farther inland, shrubs and forests may appear where soil is deeper and salt is weaker. Higher slopes may become cooler or wetter, and mountaintops can support plants unlike those near the beach. On a large enough island, these zones may be crossed in a single day, giving the feeling of moving through several small worlds. Animals follow these patterns too, nesting, feeding, or sheltering, where conditions suit them best. The changes are not random. They reflect distance from the sea, elevation, rainfall, temperature, and exposure. An island is often read in layers. The shore, forest, slope, and summit each tell a different part of the same quiet place. The edge of an island is often the richest place because land and sea overlap there. Along the coast, waves bring nutrients, driftwood, shells, seeds, and floating life, while the land sends leaves, soil, fresh water, and shade toward the shore. Birds feed in one place and nest in another. Crabs move between beach and forest. Roots hold sand, while tides reshape it. This border zone changes daily, but it is not merely a line separating two worlds. It is a living exchange. Many island stories, from fishing and travel to nesting and farming, begin at this edge because it is where movement becomes possible. The shore can be fragile, crowded, beautiful, and useful all at once. On an island, the coastline is not the end of the land. It is the place where the island is most awake. Remote islands often become home to species found nowhere else on Earth. When plants or animals reach an isolated island, they may be separated from their mainland relatives for thousands or even millions of years. Over time, they adapt to the island's food, climate, predators, and shelter. A bird may develop a different beak, a plant may grow in an unusual shape, or an insect may lose the need for long-distance flight. This process is called endemism, and islands are famous for it because distance creates privacy for evolution. The water around the island works like a quiet wall, allowing small changes to build into something unique. These species can make an island feel like a natural library with pages that exist nowhere else. Their presence shows how life responds when it has a small world almost to itself. The Galapagos Islands helped scientists understand how isolation can shape living things. These volcanic islands in the Pacific are home to animals that vary from island to island, including famous finches with different beak shapes. Some beaks are better for cracking seeds, while others suit insects, cactus flowers, or other foods. Charles Darwin visited the islands in 1835, and later evidence from places like the Galapagos helped support the idea that species change over time through natural selection. The islands did not provide a single simple answer all at once, but they became part of a much larger scientific story. Their calm beaches, dry slopes, and rocky shores hold clear examples of life adapting to local conditions. A short distance across the water can be enough to give evolution a different path. Madagascar holds an extraordinary island world because it has been isolated for a very long time. The island lies off the east coast of Africa, but much of its wildlife followed a separate path. Lemurs are the best known example, with many species living in forests, dry woodlands, and scrubby landscapes across the island. They are primates, yet they are not monkeys or apes, and their long history on Madagascar allowed them to fill many ecological roles. The island is also known for baobab trees, chameleons, and many plants and animals found nowhere else. This richness comes from a mix of ancient isolation, varied habitats, and long evolutionary time. Madagascar shows how an island can become more than a smaller version of a continent. It can become a whole branch of life, growing in its own quiet direction. New Zealand's native birds evolved in a land where native land mammals were almost absent. Before humans arrived, the only native land mammals were bats, while seals and other marine mammals lived around the coasts. With few mammal predators on land, birds filled many roles that mammals often fill elsewhere. Some birds became large, some became strong walkers, and some lost the ability to fly. The kiwi, for example, is a small nocturnal bird with nostrils near the tip of its long bill, useful for sensing food in the ground. The extinct moa grew much larger and browsed on plants like grazing animals. This unusual bird-shaped world developed because the islands were far from other land and had their own ecological rules. New Zealand shows how life can rearrange itself when familiar mainland pressures are missing. On islands, absence can be as powerful as presence. Over long periods of isolation, animals on islands can become smaller or larger than their mainland relatives. This pattern is often called island dwarfism or island gigantism, though it does not happen in every case. Large animals may become smaller when food and space are limited, while small animals may become larger when there are fewer predators or competitors. Fossils from Mediterranean islands show that dwarf elephants once lived there, much smaller than their mainland ancestors. On some islands, rodents, birds, or reptiles have taken on unusually large forms. These changes are not magical or sudden. They are the result of many generations responding to a particular place. An island can change the pressures of survival by shrinking ranges, removing rivals, or altering food supplies. In that quiet experiment, body size itself may become part of the island's story. Many island insects lose the ability to fly when strong winds make flight risky. On exposed islands, especially in windy southern oceans or high latitudes, a small insect that flies too easily may be blown out to sea. Over generations, insects that stay close to the ground can have a better chance of surviving and reproducing. Some beetles, moths, flies, and other insects on islands have reduced wings or no useful wings at all. This may seem surprising, because flight is usually a powerful advantage. On a small, windy island, it can become a danger. Life adapts not to what is generally useful, but to what works in a particular setting. The result is a quiet reversal of expectations. The island does not simply isolate these insects. It changes the meaning of movement itself. Flightless rails evolved again and again on islands, where walking was safer than flying. Rails are a family of birds that often reach islands naturally, because many can fly well enough to cross water. Once they settle in a place with few land predators, flight may become less necessary over many generations. Wings can shrink, bodies can become heavier, and the birds may spend more time moving through grass, forest, or marsh on foot. This pattern has appeared on many oceanic islands, though it has also made such birds vulnerable when cats, rats, dogs, or people arrived. The story is both fascinating and fragile. A rail may lose flight because its island once gave it safety, then become endangered when that safety changes. These birds show how evolution can make life beautifully suited to one world, but poorly prepared for a different one. Giant tortoises became lasting symbols of island life because they can survive where food and water are seasonal. On islands such as the Galapagos and Aldabra, tortoises move slowly through dry grasslands, scrub, and shaded places, feeding on plants and storing water in their bodies. Their large size helps them endure long periods when resources are limited. They also shape the landscape by grazing, spreading seeds, and opening paths through vegetation. For many plants, a tortoise is not only a feeder, but a carrier that moves seeds across the island in a living journey. Their long lives make them feel like witnesses to slow change, though they are active parts of their ecosystems. A giant tortoise turns patience into a way of life. Its quiet movement links soil, seed, shade, and season across the island ground. The marine iguana of the Galapagos is the only lizard that regularly feeds in the sea. It lives on rocky shores, where it basks in the sun before entering cold water to graze on algae. Its flattened tail helps it swim, and its strong claws grip slippery rocks in the surf. After feeding, it often returns to land to warm itself again, because the ocean can quickly lower its body temperature. Marine iguanas also sneeze out excess salt through special glands, leaving pale crusts on their heads. Their dark color helps them absorb heat from the sun after swimming. This animal is a clear example of island adaptation because its life is tied to volcanic shores, algae-covered rocks, and few land food sources. It looks unusual because it is doing something unusual, living as a shoreline reptile of both land and sea. On a few Indonesian islands, Komodo dragons became the largest living lizards. These powerful reptiles live naturally on Komodo, Rinca, Gili Motang, and parts of Flores, with dry forests, savannas, and rugged hills forming much of their habitat. Their island world shaped a life of patience, scent, and strength. A Komodo dragon uses its forked tongue to gather chemical traces from the air, helping it find food over distance. It can eat deer, wild pigs, birds, and smaller reptiles, and younger dragons often spend time in trees to avoid danger from adults. Their existence shows how an island can hold a creature that feels ancient without being mythical. They are not monsters from a story. They are real animals, shaped by limited ranges, local prey, and long adaptation. In limited island worlds, Snakes sometimes follow unusual evolutionary paths because food, predators, and space are limited. On some islands, snakes become specialized for certain prey, such as seabird chicks, lizards, eggs, or fish near the shore. In other places, snakes are absent altogether, which can allow birds, reptiles, or small mammals to behave differently than they might on a mainland. When snakes are introduced to islands where native animals evolved without them, the results can be severe. The brown tree snake on Guam is a well-known example, associated with major losses of native forest birds after its accidental arrival. This shows how a single predator can alter a small ecosystem. Islands make such changes easier to see because the boundaries are clear. The presence or absence of one animal can reshape the quiet balance of an entire place. Bats can be crucial island pollinators and seed carriers, especially where few other mammals are present. Many islands have native bats even when land mammals are rare, because bats can cross water by flying. Fruit bats may feed on nectar, pollen, or soft fruit, moving between trees at night and carrying life from one place to another. When they drop seeds in flight or after feeding, they help forests spread and recover. Nectar-feeding bats can pollinate flowers that open after dark, often guided by scent and pale color. Their work is easy to miss because it happens in the evening or night, above the quiet canopy. On some islands, the health of a forest depends partly on these winged mammals. A bat crossing a moonlit valley may be carrying tomorrow's trees in its mouth, fur, or memory of flowers. The flowers of an island are often shaped by the animals that pollinate them. On some islands, birds, bats, moths, bees, or even lizards carry pollen from one bloom to another. Where certain pollinators are common and others are absent, flowers may evolve particular colors, shapes, scents, or nectar rewards. Bird-pollinated flowers are often bright and tubular, while moth-pollinated flowers may open at night and release stronger scents. Some island plants become highly dependent on one or a few pollinators, which can make them vulnerable if those animals decline. The relationship is delicate but beautiful. A flower is not only decoration on an island hillside, it is part of a small agreement between species, shaped through many generations. In a place surrounded by water, the meeting between a bloom and its visitor can help hold an entire plant community together. On many island beaches, sea turtles return to the same shore where they first entered the sea. Female sea turtles can cross wide ocean distances and come ashore to lay eggs in sand, sometimes on the island or coastline where they hatched. Scientists think they use several cues, including Earth's magnetic field, smell, currents, and coastal features, though the full process is complex. The nesting beach must be suitable, sandy enough for digging, high enough to avoid ordinary waves, and quiet enough for the eggs to develop. When hatchlings emerge, they move toward the brighter open horizon over the sea. Islands with protected beaches can be important nesting sites because they offer stretches of sand away from dense development. The return of turtles links generations to a particular shore. The island becomes not just a place, but a remembered point in the ocean. Land crabs can carry the energy of the shore deep into island forests. Many island crabs spend part of their lives near the sea, especially when their young must develop in salt water. But adults may live inland among roots, leaves, and burrows. They feed on fallen fruit, seedlings, dead animals, and plant litter, helping recycle nutrients through the soil. During breeding seasons, some species migrate toward the coast in large numbers connecting forest paths with beaches and tide lines. Their burrows can loosen soil and create small spaces where water and air enter the ground. On islands with few native mammals, crabs may become especially important workers in the forest floor. They are not only beach creatures moving sideways in the sand. They are part of a larger island rhythm, linking dark leaf litter with moonlit water. Seabird colonies can carry the nutrients of the ocean onto the land. Many seabirds feed far out at sea, then return to islands to rest, nest, and raise their young. Their droppings, often called guano, when they build up in large amounts, add nitrogen and phosphorus to thin island soils. Feathers, eggshells, and fallen food add to the same exchange. Over time, this can help grasses, shrubs, and even small forests grow more richly than they might otherwise, especially on rocky or sandy islands where ordinary soil is limited. In this way, seabirds act like messengers between water and land, carrying the sea's energy back to cliffs and nesting slopes. Fish become food for birds. Birds nourish plants, and the island becomes part of a wider ocean cycle. Many small islands are important nesting places because water can protect eggs and chicks from some predators. Birds that nest on the ground are often vulnerable on mainlands, where foxes, cats, rats, snakes, or other animals may find them easily. An island without those predators can become a safer place to raise young. This is why conservationists sometimes work hard to remove introduced predators from islands and protect nesting colonies. The difference can be dramatic, especially for seabirds that return to the same breeding sites year after year. A quiet island beach, cliff ledge, or grassy slope may hold thousands of nests because the surrounding water creates a natural defense. The island does not need to be large to matter. For a bird looking for a safe place to begin life, even a small rock offshore can be valuable. Subantarctic islands support dense wildlife colonies in some of the coldest ocean regions. These islands lie between the warmer temperate world and Antarctica, surrounded by rough seas, strong winds, and nutrient-rich waters. On land, the climate can be chilly, wet, and treeless, with grasses, mosses, lichens, and cushion plants close to the ground. Along the shores, penguins, albatrosses, petrels, seals, and sea lions may gather in large numbers to breed or rest. Their abundance comes from the sea around them, where currents bring nutrients that feed plankton, fish, and squid. The island itself may look bare from a distance, but it becomes a crowded meeting place for ocean life. These islands show how a cold, remote shore can be full of energy, carried in from waves, wind, and deep water. For birds crossing seas and continents, islands can act as stepping stones. Migrating birds often need places to rest, feed, or wait for better weather during long journeys. A small island on a route may be critical even if it has little fresh water or only low vegetation. Shorebirds may pause on mudflats, songbirds may shelter in shrubs, and seabirds may return to familiar cliffs or beaches. Some islands are especially important because they sit between larger land masses, turning a dangerous open water crossing into a series of shorter flights. Weather can make these stops even more valuable, as tired birds may arrive after storms or strong headwinds. To a person, the island may seem quiet and empty. To a migrating bird, it can be a safe comma in a sentence written across the sky. Uninhabited islands can still be busy places for plants, animals, wind, and water. The absence of permanent human settlement does not mean an island is empty. Birds may nest there in great numbers, turtles may come ashore at night. Crabs may cross the beach, and seeds may take root in sheltered soil. Weather writes its own patterns through dunes, grasses, driftwood, and tide lines. Some uninhabited islands are protected because they give wildlife a place with little disturbance. Others are difficult to settle because they lack fresh water, safe landing places, or good soil. Their quietness can make them valuable, not useless. They show what an island can be when human routines do not fill the space. The land still has a schedule, but it is kept by tides, nesting seasons, rain, flowering plants, and the movement of animals. Socotra is known for unusual plants shaped by isolation and dry island conditions. This island, part of Yemen, lies in the Arabian Sea and has many species found nowhere else. Its best-known tree is the dragon's blood tree, with a broad, umbrella-like crown that helps shade its own roots and reduce water loss. The tree's red resin gave it its memorable name and has been used by people for many purposes over time. Socotra's landscapes include limestone plateaus, coastal plains, mountains, and dry valleys, creating a variety of habitats in a relatively compact space. The island's plants often look strange because they are well suited to harsh sun, seasonal moisture, and long separation. Socotra feels like a reminder that beauty in nature is often practical. A remarkable shape may simply be a quiet answer to a difficult climate. In places such as the Canary Islands and Madeira, older plant communities can survive after disappearing from nearby mainlands. These places are sometimes called refuges because their climates, isolation, or difficult access allowed old lineages to survive. The Canary Islands and Madeira, for example, still have laurel forests related to vegetation that was once more widespread around parts of the Mediterranean region. As climates changed elsewhere, island mountains and moist slopes protected fragments of that older world. Such forests can feel ancient not because every tree is old, but because the community has deep roots in Earth's changing climate history. Islands can keep these living memories when continents become too dry, too cold, or too altered. A sheltered valley may hold plants whose wider relatives vanished from other landscapes. In this way, an island can become a green archive, preserving a softer echo of vanished forests. On some oceanic islands, plants can become woody even when their mainland relatives are soft herbs. This pattern, often called island woodiness, appears in several plant groups on oceanic islands. In a mild island climate, with fewer grazing animals or seasonal extremes, a plant that might remain small elsewhere can slowly evolve thicker stems and a shrub-like or tree-like form. Being woody may help it live longer, grow taller, and compete for light in stable conditions. The change does not happen to all plants, and each island has its own history, but the pattern is one of the charming surprises of island botany. It shows that familiar plant families can take unfamiliar shapes when they settle in a different world. On an island slope, something related to a modest wildflower may stand as a small tree, quietly rewriting expectations. Along exposed island coasts, plants often grow low and tough because wind and salt make height difficult. Along exposed coasts, strong breezes can break branches, dry leaves, and carry salt spray far inland. Plants that survive there often have waxy leaves, flexible stems, thick skins, or cushion-like shapes close to the ground. These forms reduce water loss and protect growing tips from harsh air. On cliffs and dunes, roots may spread widely to grip thin soil or shifting sand. The result can be a landscape that looks trimmed by an invisible hand, with shrubs leaning away from the sea and grasses bending in one direction. The plants are not stunted in a careless sense. They are shaped by constant conditions. Their low profiles and silver leaves are practical answers to a windy life at the island's edge. Coconut palms spread widely across tropical islands because their seeds can float across salt water. A coconut is not only food, it is a tough traveling vessel. Its fibrous husk helps it stay buoyant, while the hard inner shell protects the seed inside. When a coconut washes onto a suitable warm shore, it may sprout above the tide line and begin growing in sandy soil. People also carry coconuts deliberately across the tropics, so their spread is both natural and cultural. On islands, the palm became useful for food, drink, fiber, building materials, oil, and shade. Its curved shape along a beach is familiar, but its success comes from practical design. The tree is well suited to coastlines where salt, wind, and shifting sand challenge many other plants. A coconut palm is a quiet symbol of travel by water. Even where rainfall is limited, fog can provide water to an island. On some dry islands, moist air from the sea moves inland as fog and meets cool slopes, ridges, or forests. Leaves, needles, mosses, and branches catch tiny droplets, which gather and drip to the ground. This process is sometimes called fog drip, and it can help support plants in places that would otherwise be much drier. Cloud forests, coastal scrub, and highland woods may depend partly on this hidden water source. The effect is subtle because it does not sound like rain or arrive in heavy drops. It gathers quietly on surfaces and enters the soil little by little. An island can therefore receive water from the air without a storm. Fog becomes a soft kind of rainfall, delivered by wind, captured by leaves, and stored in shade. Cloud forests can grow on island mountains where moist sea air becomes trapped in cool, high places. These forests often sit above warmer lowlands, wrapped in mist for much of the year. Water gathers not only as rain, but as tiny droplets caught by leaves, mosses, bark, and hanging roots. This steady moisture can support ferns, orchids, lichens, and trees covered in soft green growth. On islands, cloud forests may be small because they exist only at certain elevations where temperature and moisture meet. That makes them rich but fragile habitats. A short climb from the shore can lead from dry slopes to a hidden world of dripping branches and pale fog. These forests show how an island can hold several climates stacked above one another. The sea sends the clouds, the mountain holds them, and life gathers quietly in between. Because many island forests evolved with fewer threats than mainland forests, they can be unusually vulnerable. Trees and understory plants may be adapted to local birds, insects, winds, and soils, but not to introduce grazers, far-spreading weeds, or new plant diseases. When goats, rats, pigs, or invasive plants reach an island, they can change a forest quickly, especially if native species have no defenses against them. At the same time, island forests can recover when careful protection allows seedlings to grow and native animals to return. Their small size makes damage visible, but it can also make restoration possible on a human scale. A valley, ridge, or offshore islet may become a refuge for rare plants. Island forests show how delicate and resilient nature can be at once. They are living rooms of shade, shaped by long isolation. Introduced rats have changed many island ecosystems because they can reach nests, seeds, and small animals that evolved without them. Rats often arrive by ship, sometimes accidentally, and they spread easily where food and shelter were available. On islands with ground-nesting birds, they may eat eggs and chicks. They can also consume seeds, insects, lizards, and young plants, quietly shifting the whole web of life. Because islands are bounded by water, conservation teams have sometimes been able to remove rats from carefully chosen islands and watch native wildlife recover. These projects require planning and long monitoring, but they show how much difference one introduced animal can make. The story is not only about harm, it is also about repair. An island can reveal ecological change clearly, and when pressure is reduced, its native life may begin to return. For species with small ranges, extinction risk is often higher on islands because ecological balances can be fragile. A species found on only one island may have nowhere else to go if its habitat is damaged. A new predator arrives, or disease spreads. Birds that nest on the ground, plants with few remaining pollinators, and animals with small populations can be especially vulnerable. Many island species evolved without certain mainland pressures, so they may not respond quickly to cats, rats, goats, snakes, or aggressive weeds. This can sound bleak, but islands have also become places where recovery is possible. Because boundaries are clear, conservation work can remove invasive species, protect nesting areas, restore forests, and monitor rare life closely. Island extinction teaches a serious lesson in a quiet way. A small world can hold unique life, and unique life needs careful room to continue. Some islands are protected as nature reserves because their small size makes rare life easier to defend. A reserve may cover an entire island, a group of offshore rocks, or a section of coast where seabirds, reptiles, plants, or marine life need shelter. The surrounding water can help managers control access, reduce disturbance, and prevent some invasive species from arriving. This does not make protection simple, because storms, climate change, illegal collecting, and accidental introductions can still cause problems. Yet islands can be powerful places for conservation because boundaries are clear. A small island may hold the last safe breeding site for a species, or a restored forest may become a stepping stone for recovery. The quietness of a reserve is not emptiness. It is careful space, set aside so that fragile life can continue its slow work. Coral lagoons are sheltered island waters, where young marine life can find food and protection. A lagoon may sit inside a reef, behind a chain of coral, or within the pale ring of an atoll. Because waves break on the outer reef, the water inside is often calmer than the open sea. Seagrass beds, coral heads, sandy patches, and shallow channels create many small habitats close together. Young fish can hide from larger predators, while crabs, mollusks, rays, and other animals move through the warm shallows. Sunlight reaches the bottom in many lagoons, helping plants and algae support the food web. The scene may look still from above, like blue glass held by white sand, but the water is full of quiet movement. A lagoon is not an empty space inside an island system. It is a nursery wrapped in light. Tide pools on island shores can hold tiny worlds between the sea and the land. When the tide goes out, seawater remains in hollows of rock, leaving small pools filled with algae, shells, crabs, snails, anemones, and sometimes little fish. These creatures must handle changing conditions because the pool may become warmer, saltier, cooler, or more exposed before the tide returns. Waves can refresh the water, but they can also bring strong force and sudden change. On many rocky islands, tide pools reveal how life adapts to a narrow strip of time and space. The animals are not simply stranded there. They are suited to this repeating rhythm of cover and exposure. Each pool is like a small window into the shore's daily pulse, showing the sea in miniature, while the larger ocean waits nearby. Reefs growing offshore can quiet the sea before it reaches the island shore. A reef growing offshore works like a living breakwater, causing waves to lose some of their force as they pass over shallow coral, rock, or reef flats. Behind the reef, the water may become calmer, allowing lagoons, seagrass beds, mangroves, and sandy beaches to form in more sheltered conditions. This protection is not absolute, because storms can still send powerful water across reefs and onto land. Yet in ordinary weather, reefs often soften the meeting between ocean and island. They also create many small homes for marine life, from hiding places between coral branches to sandy channels where rays and fish move slowly. A reef is therefore both a structure and a community. It protects the island while being built by life that depends on sunlight, clean water, and time. Seagrass meadows around islands can shelter young fish in calm, shallow water. These underwater plants are not seaweed, but flowering plants that grow from the seabed with roots, stems, and long blades. Around islands, they often spread across sandy lagoons, sheltered bays, and clear coastal flats where sunlight can reach them. Small fish hide among the blades, turtles graze on them, and crabs, snails, and seahorses may move through the meadow. Seagrass roots help hold sediment in place, which can keep the water clearer and protect nearby reefs from too much drifting silt. These meadows can also store carbon in their buried soils for long periods. From above, they may look like dark green patches under the surface. Within the water, they are quiet pastures, nurseries, and anchors for the island's coastal life. Kelp forests around cool islands can be as rich and layered as forests on land. Kelp is a large brown seaweed that grows from the seafloor toward the surface, forming tall underwater stands in cold, nutrient-rich water. Around rocky islands, kelp can create shelter for fish, crabs, sea urchins, snails, and many other creatures. Sea otters, seals, seabirds, and larger fish may also depend on this web of life. The kelp moves with waves rather than standing stiffly, so the forest sways and bends in a slow underwater rhythm. Unlike trees, kelp can grow quickly when conditions are good, but it is still vulnerable to warming water, storms, grazing animals, and pollution. From above, a kelp bed may look like dark patches near the shore. Beneath the surface, it is a living island border, dense with movement. Atoll passes are openings that let ocean water move between a lagoon and the outer sea. These gaps may form where waves, currents, storms, or older river channels shape the reef structure over time. A pass can be very important for boats, fish, nutrients, and the health of the lagoon. Water flowing through it refreshes the inner shallows, carrying larvae, plankton, and dissolved oxygen. For island communities, a safe pass may decide where boats enter, where fishing is easiest, and where settlements grow. Passes can also be challenging, because tides may create strong currents as water rushes in or out. The opening is both doorway and moving river. In an atoll, the lagoon may look enclosed and calm, but the pass reminds us that it is always breathing with the larger ocean. A beach on an island can be made from shells, coral, rock, quartz, or even the remains of tiny sea creatures. White tropical sand is often linked to broken coral, shells, and the hard parts of marine organisms ground down by waves and grazing fish. Pale quartz sand may come from older continental rocks and rivers. Some beaches are pink because red fragments of shells or coral mix with lighter grains. Others are greenish where minerals such as olivine are present in volcanic areas. The color of a beach is a clue to the island's geology and nearby life. Each grain has a source and a journey, even if it is too small to notice. A beach is not simply soft ground beside water. It is a gathering place for broken stone and former life, sorted by waves into a smooth shore. Blue caves and glowing sea grottos often owe their color to sunlight passing through water. In some island caves, light enters through an underwater opening or reflects from a pale sandy bottom below the surface. Water absorbs and scatters light in ways that can make the cave appear blue, turquoise, or silver from inside. The effect depends on the angle of the sun, the shape of the entrance, the depth of the water, and the clarity of the sea. Such caves are not glowing by themselves. They are shaped chambers where rock, water, and light meet at just the right moment. Waves may echo softly against the walls, and the ceiling may remain dark above the illuminated water. A sea grotto is a reminder that islands can hide their brightest colors in shadow. Bioluminescent bays glow when tiny organisms produce light in disturbed water. In a few sheltered island bays and lagoons, large numbers of dinoflagellates can gather, where water circulation, mangroves, nutrients, and local shape create suitable conditions. When a paddle, fish, or hand moves through the water, the organisms may flash blue-green for a moment. The light is a biological reaction, not a reflection from the moon. Famous examples occur in Puerto Rico, where protected bays have become known for this soft nighttime glow. These places are sensitive because pollution, heavy disturbance, and changes in water flow can affect the organisms that create the light. A glowing bay shows that an island's wonder is not always on the mountain or beach. Sometimes it appears in the shallow water after dark, sparked by life too small to see clearly. Sea stacks can become miniature islands for plants and birds when erosion cuts them away from the shore. A stack begins as part of a cliff or headland, then waves and weather remove the weaker connections around it. Once isolated, its steep sides may protect nesting seabirds from many ground predators. Seeds can arrive by wind, bird droppings, or sea spray, taking root in cracks where a little soil gathers. The top may become a small meadow, a patch of shrubs, or a bare platform depending on wind and salt. From the mainland, a sea stack can look like a lonely column of stone, but it may hold a dense little community. Its isolation is small in distance, yet large in effect. A few meters of water can turn ordinary cliff rock into a refuge. Along exposed coasts, cliffs are often shaped by the steady pressure of waves below and weather above. The sea undercuts the base, especially where rock is weak or cracked, while rain and wind loosen material higher up. Pieces fall away, and the cliff slowly retreats. On many islands, these steep edges become important homes for seabirds, which nest on ledges beyond the easy reach of many land predators. Plants may cling to cracks, using thin soil and salt-tolerant leaves to survive in the wind. The cliff can look severe, but it is full of small shelters, shelves, and hidden growth. Its face may reveal layers of lava, limestone, sandstone, or ancient reef, depending on the island's history. A cliff is both boundary and record. It shows where the land meets the sea and how that meeting changes the land over time. Whales often use island waters as places to feed, rest, breed, or pass during migration. Islands can sit near deep channels, productive currents, or sheltered bays that matter to different whale species. Humpback whales, for example, are known for traveling between colder feeding areas and warmer breeding grounds, and some island regions become seasonal gathering places. The shape of the seafloor may guide prey into certain areas, while quieter bays can offer calmer water for mothers and calves. For island communities, whale arrivals may mark a season, a tradition, or a reason for careful protection. Watching a whale near an island can make the scale of the ocean feel close and understandable. The animal rises, breathes, and sinks again beside land. In that moment, the island becomes a shore not only for people, but for a far-traveling life. Deep water close to volcanic islands can bring large ocean animals near the shore. Many volcanic islands rise steeply from the seafloor, so the ocean may become very deep within a short distance of land. This allows whales, dolphins, Chirua's sharks, and other open water species to pass close to cliffs, harbors, or beaches. Upwelling currents and underwater slopes can concentrate food, drawing smaller fish and the larger animals that follow them. For people on the island, the open ocean can feel surprisingly near, not far beyond a shallow continental shelf. A person may stand on land and look out over water that drops quickly into darkness. This steep meeting of island and sea creates a sense of closeness between shore life and deep marine life. The island is a mountaintop, and the sea around it is a hidden valley. Shipwrecks around islands can become unexpected reefs when solid structures settle on the seafloor. Over time, algae, barnacles, corals, sponges, and other organisms may attach to the exposed surfaces. Small fish find shelter in gaps, larger fish patrol the edges, and the wreck slowly becomes part of the underwater landscape. This does not make every wreck harmless, because fuel, cargo, metal, and disturbance can create environmental problems. Yet when conditions are suitable and dangers are managed, a wreck can provide hard habitat where the seafloor is otherwise sandy or flat. Around islands, wrecks often tell of reefs, storms, navigation challenges, or busy trade routes. They are human objects taken over by marine life. The shape of a ship may remain recognizable for a while, but the sea gradually covers it with growth, shadow, and movement. Old vessels can gather in quiet boat graveyards where sheltered mud or shallow water holds them in place. Wooden boats may slowly decay among reeds, salt marsh, mangroves, or quiet harbor edges, while metal hulls rust and settle into the sediment. These places can look melancholy, but they also reveal working histories of fishing, transport, trade, and repair. A boat may have carried families, nets, crops, animals, building materials, or mail before becoming too worn to use. Over time, birds may perch on its ribs, plants may grow nearby, and tides may move through the broken frame. The vessel becomes part artifact, part habitat, and part shoreline feature. A boat graveyard reminds us that island life depends on crossings. Even after its journey's end, a boat can continue to mark the meeting of people and water. Ocean currents help decide what washes onto island beaches from far beyond the horizon. Seeds, driftwood, pumice, shells, seaweed, and human-made objects can travel for weeks or months before reaching shore. Some floating seeds are tough enough to survive saltwater journeys and still grow when they land on a suitable beach. This is one reason certain coastal plants are found on many tropical islands separated by wide water. Currents can also carry rafts of vegetation, small animals, or pieces of reef after storms. Not every arrival survives, but each one is a chance. A beach is not only an edge where waves end, it is a receiving place for distant stories carried by moving water. The line of debris left by the tide can reveal the island's connection to a much larger ocean system. Pumice rafts can carry living things across the sea after volcanic eruptions. Pumice is a light, gas-filled volcanic rock, and some pieces are so full of tiny holes that they can float. When an underwater or island eruption releases large amounts of pumice, the fragments may drift together in broad rafts moved by wind and currents. Small organisms can cling to them, including barnacles, algae, crabs, snails, and sometimes tiny coral or plant life. Most travelers will not survive or find a suitable new home, but the journey still matters. A pumice raft can become a temporary floating island, crossing distances that many creatures could not travel alone. It shows that islands are not only fixed points of land, they are also connected by drifting materials, chance arrivals, and the slow wandering of the ocean itself. Black sand beaches often form when volcanic rock is broken down by waves. On volcanic islands, lava can cool into dark basalt, and the sea slowly grinds pieces of it into smaller grains. The result may be a beach that looks charcoal, silver, or deep black depending on the light and moisture. These beaches can be striking, but they are not usually permanent in exactly the same shape. Waves sort the grains, storms move them, and new volcanic material may sometimes add to the supply. Black sand can also warm quickly in sunlight because dark surfaces absorb heat. Around such beaches, green plants, pale surf, and dark shorelines create a strong contrast. The color is not a decoration added to the island. It is a quiet clue to the island's fiery origin and the patient work of the sea. Surtsey became a rare natural laboratory when it rose from the sea near Iceland in 1963. The island formed during an underwater volcanic eruption, and scientists carefully protected it so they could watch how life arrives on new land. At first, Surtsey was bare rock, ash, and loose volcanic material, exposed to wind, waves, and weather. Seeds arrived by wind, sea currents, and birds. Insects appeared, plants took root, and seabirds later helped enrich the soil. Because human disturbance was kept very limited, the island gave researchers an unusually clear view of colonization in action. Surtsey shows that a new island is not empty for long, even when it begins as raw volcanic ground. Life reaches outward with patience, using air, water, wings, and chance to begin the slow making of an ecosystem. Because their boundaries are clear, islands are useful for science. Researchers can compare one island with another to understand evolution, conservation, geology, climate, language, disease, or human settlement. The surrounding water does not make an island simple, but it does help define the system being studied. Scientists can ask which species arrived, which stayed, which changed, and how distance or size affected the results. This is one reason island biogeography became an important field, exploring how area and isolation influence the number of species on islands. The same idea can apply more broadly, because islands help reveal relationships that may be harder to see on large continents. A good island study is not about treating the place as empty. It is about paying close attention to a bounded world with its own history. Volcanic island soils can become very fertile after weathering turns fresh rock into mineral-rich earth. New lava is hard and bare at first, but rain, heat, plant roots, lichens, and tiny organisms slowly break it apart. As the rock weakens, minerals are released into young soil. Fallen leaves and decaying roots add organic matter, helping the surface hold water and support more plants. In warm, wet climates, this process can happen quickly compared with colder places, though full soil development still takes time. Many volcanic islands have supported farming because their soils can be productive once they are stable enough to cultivate. The fertility does not come from the eruption alone. It comes from the long softening of stone into ground that roots can enter. A dark volcanic slope may one day become a field, orchard, or forest. Volcanic ash can preserve delicate shapes when it falls gently over a landscape. During some eruptions, fine ash settles over leaves, footprints, buildings, fields, or forest floors. Later, if conditions are right, these layers can protect traces that might otherwise vanish. On islands with volcanic histories, ash beds may help scientists date events, study past vegetation, or understand how people and animals lived near active volcanoes. Ash can also change soil over time, adding minerals after weathering, though fresh ash may first be difficult for plants and people. Its role is therefore complex. It can cover, harm, nourish, and preserve. A grey layer on an island hillside may look plain, but it can act like a timestamp. It marks a moment when the sky briefly became part of the ground. Lava tubes on the volcanic islands form when the outside of a lava flow cools, while molten rock continues moving inside. When the flow drains away, it can leave a hollow tunnel beneath the surface. These tubes may stretch through dark ground like underground passages made by fire. Over time, they can become shelters for insects, bats, roots, moisture, and mineral deposits. Some lava tubes hold skylights where the roof has collapsed, allowing ferns or small trees to grow in sudden shafts of light. They can also preserve traces of older eruptions and show how lava once traveled across the island. A lava tube is not a cave carved by water. It is the empty memory of movement, left behind when flowing rock cooled and disappeared. Beneath a quiet slope, the island may still hold the shape of its fiery past. In sheltered chambers under the ground, caves can preserve quiet records of past climates, animals, and human visits. Some caves form in limestone as slightly acidic water dissolves the rock, while others appear in volcanic lava flows or sea cliffs. Inside, sheltered conditions may protect bones, shells d'etat, charcoal, tools, pollen, or mineral deposits from weathering. Stalactites and stalagmites can grow slowly from dripping water, storing chemical clues about rainfall and temperature in their layers. On islands, these records are especially valuable because outside landscapes may be quickly changed by wind, salt, storms, and erosion. A cave can become a still room inside a restless place. Scientists study such spaces carefully because small traces may tell long stories about extinct animals, changing shorelines, or the arrival of people. The cave keeps its evidence quietly, away from the bright movements of the coast. In flooded caves and underground pools, rare island animals can live in darkness. In limestone or lava landscapes, underground pools and flooded passages may hold tiny crustaceans, blind fish, worms, or insects that live far from sunlight. Many of these creatures are pale, slow-growing, and sensitive to changes in water quality. Because each cave system can be isolated from others, its animals may be found nowhere else. The water inside may come from rain filtering through rock, making it vulnerable to pollution from the surface. These hidden ecosystems are difficult to see, but they are part of the island's living world. A cave pool may look still and empty under a lamp, yet contain species shaped by darkness over immense spans of time. On an island, even the unseen water beneath the ground can become a separate world. In volcanic regions, underground heat can give islands hot springs. In volcanic regions, rain and groundwater may sink through cracks in the rock, pass near hot volcanic material, and rise again as warm or steaming springs. Some springs appear near beaches, cliffs, valleys, or crater slopes, depending on the island's geology. Minerals dissolved in the water can leave pale deposits, unusual colors, or a faint scent. People have used hot springs for bathing, washing, cooking, and healing traditions in many cultures, though each place has its own history and rules. The spring is a gentle surface sign of heat below. It reminds us that some islands are not only shaped by past eruptions, they still hold warmth inside, turning rainwater into quiet pools that steam in cool air. Crater lakes on volcanic islands can form when rainwater fills an old volcanic hollow. After an eruption ends or volcano becomes quiet, a crater or caldera may remain near the summit. If the rock and climate allow water to collect, the hollow can become a lake, sometimes high above the surrounding sea. These lakes may be clear, dark, warm, acidic, or mineral-rich depending on local geology and remaining volcanic heat. Some are surrounded by steep walls, making them feel separate even within the island itself. Plants may grow along the rim, birds may visit the water, and clouds may drift below the crater edge. A crater lake is a calm surface resting inside a once active opening in the earth. It shows how a place made by eruption can later hold stillness, reflection, and rain. In a few places, lakes on islands contain islands of their own, creating land inside water, inside land, inside water. This nesting can continue in rare cases, with small ponds on lake islands holding even smaller pieces of land. The idea sounds playful, but it is a real result of uneven terrain, glacial carving, volcanic craters, or flooded basins. Manitoulin Island in Lake Huron is well known for having many lakes on it, including Lake Manitou, which is among the largest lakes on an island. These layered landscapes make boundaries feel almost dreamlike. A person can stand on an island beside a lake, looking at another island, all while surrounded by a much larger lake. The pattern shows how water can draw circles within circles. Islands are not always simple shapes on a map. Sometimes they are quiet puzzles of nested shores. Fresh water on low coral islands often rests in a thin underground lens above seawater. Rain soaks into sandy ground, and because fresh water is less dense than salt water, it can float in a curved layer below the surface. This hidden lens may be the island's most important source of drinking water for plants, animals, and people. It is delicate because too much pumping can draw salt water upward, and storm waves can wash salt across the land. The lens depends on rainfall, soil, vegetation, and the island's shape. From above, a coral island may look like sand, palms, and lagoon, but beneath it lies a quiet balance between fresh and salt. The water is not stored in a deep mountain spring. It is held gently inside porous ground, protected by gravity and renewed by rain. Some islands have no permanent rivers because their rock and climate do not hold surface water easily. Rain may fall, but it can sink quickly through porous limestone, coral sand, or fractured volcanic rock. In dry climates, streams may flow only after storms, then vanish into the ground or evaporate. People and wildlife on such islands may depend on wells, rainwater collection, dew, springs, or imported water. Plants often adapt by storing moisture, growing deep roots, or reducing water loss through thick leaves. The lack of rivers changes settlement, farming, and daily life. It also makes fresh water one of the island's most precious hidden features. From the shore, an island may look green and generous, but its water balance can be delicate. The most important stream may be underground, moving quietly through stone. Shoreline springs can appear where fresh groundwater flows out near the sea. On some islands, rainwater sinks into hills, lava rock, limestone, or sandy ground, then moves slowly underground until it emerges at a beach, cliff, or shallow seabed. The fresh water may bubble up through sand, form a small pool above the tide, or create a cooler patch in coastal water. People have used such springs for drinking, washing, and navigation, especially on islands where surface streams are rare. Plants and animals may gather around them because fresh water is so valuable near a salty shore. These springs show that the boundary between land and sea is not simple. Beneath the visible coastline, water can travel in hidden paths. A beach spring is rain returning quietly after passing through the island's dark interior. Freshwater wetlands can be rare shelters for island birds, insects, and plants. Islands are often surrounded by water, yet usable fresh water may be limited, especially where rain drains quickly or salt spray reaches far inland. A marsh, pond, swamp, or reed bed can therefore become one of the most important habitats on the whole island. It may hold frogs, dragonflies, ducks, rails, sedges, rushes, and small fish, depending on the region. Wetlands also slow runoff, filter sediment, and store water after rain. Their edges can be full of quiet activity, with birds stepping through reeds and insects moving over the surface. Because they are often small, island wetlands can be easily damaged by drainage, pollution, or invasive plants. Their value comes from concentration. A little fresh water can support a surprisingly large circle of life. Where high slopes meet moist sea air, a small island can make its own patterns of cloud and rain. When wind pushes damp air up a mountain, the air cools, and some of its water vapor condenses into clouds and rain. This can make the windward side of an island much wetter than the sheltered side beyond the ridge. After crossing the high ground, the air often descends warmer and drier, creating a rain shadow. On some islands, the change is visible in the landscape, with green forests, waterfalls, and mist on one slope, and dry grassland, scrub, or open lava fields on the other. A single ridge can divide abundance from dryness. In this way, island weather draws soft lines across the land, creating different habitats only a short walk apart. Trade winds have helped shape island life and travel across tropical oceans. These steady winds blow across broad belts of the earth and have long influenced sailing routes, rainfall patterns, and the shape of island climates. On many tropical islands, winds from the ocean bring moisture, cool the air, and push waves towards certain shores more often than others. Trees may lean with the prevailing breeze, and beaches may gather sand differently depending on wind and wave direction. For sailors, steady winds once made long ocean journeys more predictable, though still difficult and skillful. For island communities, they could affect planting seasons, fishing conditions, and contact with other places. Trade winds are not visible except through what they move. On an island, they can be read in clouds, palms, sails, and the constant sound of the shore. High island waterfalls often begin as clouds gathered from the surrounding sea. Moist air rises over mountains, cools, and releases rain onto steep slopes. The water gathers in streams, slips through forest, and drops over cliffs on its way back to the coast. On volcanic islands, young rock and steep terrain can make waterfalls especially dramatic because rivers have not yet worn the land into gentle shapes. Some waterfalls plunge straight toward the ocean, while others disappear into green valleys before reaching a beach or harbor. Their flow can change with seasons, storms, and dry spells, making them part of the island's breathing weather. A waterfall may look like a separate feature, but it connects sea, cloud, mountain, forest, and shore. It is the island's water cycle made visible, falling through the air in a silver line. Salt ponds on islands form where seawater gathers in shallow basins and evaporates under sun and wind. As the water disappears, salt becomes more concentrated and may crystallize along the edges or bottom. People have used such ponds for salt production in many warm coastal regions, sometimes shaping them into careful networks of pans and channels. Natural salt ponds can also provide habitat for brine shrimp, insects, and birds that feed in shallow water. Their colors may shift because of algae and microorganisms adapted to salty conditions. Salt ponds show how an island's climate can turn seawater into a mineral resource. The process is slow and quiet. Water enters, sunlight works, wind passes over the surface, and crystals remain. What looks like a simple flat pond may be a meeting of ocean chemistry, weather, and human patience. A strong storm can reshape an island coastline in a single night, even when the island itself has taken centuries to form. Strong waves may cut into dunes, move boulders, break coral, flood low ground, and carry sand across roads, fields, or beaches. Afterward, the coastline may look changed, with new channels, washover fans, or missing sections of shore. For natural systems, this disturbance can sometimes be part of renewal, moving sediment where it is needed and opening space for new growth. For people, it can be costly and difficult, especially on low islands where there is little high ground. Storms reveal that an island's edge is not a fixed border. It is a working line, revised by water and wind. Even calm beaches remember storms in their shape, their dunes, and the scattered materials left behind. Dune plants help hold low islands together by catching sand with their stems and roots. On sandy coasts, wind lifts grains from the beach and carries them inland. When the moving sand meets grasses, vines, shrubs, or other tough plants, it slows and begins to pile up. Over time, this creates dunes that protect the island from waves, salt spray, and storm flooding. The plants must survive burial, dryness, heat, and shifting ground. So many have flexible stems, deep roots, or leaves that reduce water loss. A dune may look like a simple mound, but it is partly built by living things. Without vegetation, sand can move more freely, and the shoreline may become less stable. Dune plants are quiet island engineers. They hold the beach in place by turning moving grains into sheltering land. Salt spray can shape island rocks, plants, and buildings far from the breaking waves. When wind lifts tiny droplets from the sea, it carries salt inland, where the crystals settle on leaves, stone, wood, and metal. Plants near the shore need ways to survive this drying, salty coating, such as waxy leaves, thick skins, or low growth. Buildings also feel the effect because salt can corrode metal, damage paint, and slowly weather stone or concrete. Even on clear days, the island air may carry this invisible trace of the ocean. Over years, salt spray helps mark the difference between a sheltered inland valley and an exposed headland. It is one of the sea's quietest forces. The water does not need to flood the land to change it. Sometimes it arrives as mist, grain by grain. Dust from distant continents can fertilize islands far out at sea. Winds can lift fine mineral particles from dry regions and carry them across oceans before rain or gravity brings them down. On islands with old or poor soils, this dust may add small but useful amounts of nutrients such as iron and phosphorus. The effect is especially interesting because it shows that even isolated islands receive invisible gifts from far away. A forest leaf, a reef organism, or a patch of soil may contain material that began its journey in a desert or dry plain. The process is gentle and irregular, depending on winds, storms, and climate patterns. It is easy to think of islands as cut off by water, but the sky connects them. Dust turns the atmosphere into a slow bridge between continents and remote shores. Terraces, notches, and raised beaches can record past sea levels along island coastlines. When sea level changes, or when land rises after tectonic movement, old shore features can be left above the present waves. A flat bench cut by surf, a line of rounded stones, or a notch in a cliff may show where the sea once reached. On some islands, these features help scientists understand earthquakes, uplift, climate shifts, and the long movement of oceans. They are quiet marks, often easy to miss during an ordinary walk. Yet they show that the boundary between land and sea has not always been where it is now. The island's edge has climbed, fallen, and shifted through time. A raised beach is a former shoreline held in daylight, a memory of waves written above the waves. Disappearing islands remind us that shorelines are temporary on the scale of Earth. Low islands made of sand, coral, mud, or river sediment can shrink when sea level rises, storms intensify, sediment supply changes, or protective reefs and wetlands are damaged. Some islands migrate as sand moves, while others break apart or become submerged. This does not mean all islands vanish in the same way, because rock, height, currents, human choices, and local climate all matter. Still, the possibility of loss gives islands a special kind of urgency. They are bounded worlds, but their boundaries are living lines. The same water that defines them can also revise them. A disappearing island is not only a sad image. It is a clear lesson in change, showing that land and sea have always been in conversation, and that the conversation continues. Polynesian navigators crossed huge stretches of ocean by reading natural signs with great skill. Long before modern instruments, they traveled between Pacific islands using stars, ocean swells, winds, birds, cloud forms, and the behavior of light on the horizon. This knowledge was learned through careful training and memory, not guesswork. Islands could be found even when they were below the visible horizon, because birds might fly from land, clouds might gather over high ground, or waves might bend around unseen shores. The Pacific is vast, but for skilled navigators, it held patterns that could be followed. Their voyages connected distant islands into networks of movement, kinship, exchange, and settlement. This history shows that islands were not always isolated in a human sense. To people who knew the sea, water could be a road rather than a wall. Outrigger canoes help people travel safely between islands by adding balance to narrow hulls. An outrigger is a smaller float attached to the main canoe by wooden supports, creating stability on the waves without making the boat heavy and slow. This design became especially important across parts of the Pacific and Indian Oceans, where island communities needed vessels suited to fishing, trading, visiting relatives, and long voyages. Skilled builders chose wood, fiber, shape, and lashings with care, because every detail affected how the canoe handled wind and water. The form is elegant because it answers a real problem: how to move across a shifting sea while carrying people and supplies. An island boat is not just transportation. It is a piece of knowledge shaped by generations who learned the moods of reefs, lagoons, currents, and open ocean. Lighthouses on islands were built to turn dangerous shorelines into readable signals. Before satellite navigation and modern electronic systems, sailors depended on lights, bells, horns, charts, and careful observation to avoid reefs, rocks, and narrow channels. An island lighthouse could mark a harbour entrance, warn of a hidden shoal, or show the position of a lonely coast at night. Many were placed where waves, fog, and wind made building and maintenance difficult. Their keepers often lived in isolation, following steady routines of cleaning lenses, tending lamps, and watching weather. The purpose was practical, but the image became powerful: a single light standing between land and sea. Even today, automated lighthouses still carry that quiet meaning. They remind us that islands are not only destinations. They can also be guides for people passing safely through the dark. Tidal islands are connected to the mainland at low tide and surrounded by water at high tide. Their changing access makes them feel especially magical because the path to them appears and disappears with the sea's rhythm. A causeway, sand flat, or rocky strip may be safe for a short time, then vanish beneath rising water. This pattern has shaped monasteries, forts, villages, and walking routes in many coastal places. It also demands respect, because tides can move faster than they seem, and channels may fill behind a traveller. The island itself may be close enough to see clearly from shore, yet unreachable for part of the day. Tidal islands reveal that separation is not always permanent. Sometimes islandness comes and goes, measured by the moon's pull and the slow breathing of the ocean. A sheltered harbour can turn a difficult island coast into a place of arrival, trade, repair, and rest. A good harbour can turn a difficult coast into a place of arrival, trade, repair, and rest. On some islands, safe landing places are rare, so a single sheltered bay may shape the location of a town or village for centuries. Boats need calmer water, enough depth, and protection from prevailing winds. Natural harbours may be improved with piers, breakwaters, steps, or simple stone walls. Their importance is easy to miss on a map, where every coast may look equally close to the sea. In real life, the difference between a rough shore and a sheltered inlet can decide where people settle. An island harbour is more than a gap in the coastline. It is the place where the surrounding water becomes approachable. For many communities, ferries become lifelines because they carry more than passengers. A ferry may bring groceries, mail, school children, workers, medicine, fuel, tools, animals, and visitors across the water. Its schedule can shape daily life as strongly as a road or train does elsewhere. Weather, tides, mechanical problems, or rough seas can delay travel, reminding everyone that an island's connection to the wider world is physical and sometimes uncertain. Ferry docks often become social places where people wait, greet, trade news, and watch the water. The route may be short, but its meaning is large. It turns separation into routine movement. A ferry is not simply a boat going back and forth. For many islands, it is a moving thread that stitches the shore to schools, hospitals, markets, families, and the mainland. A causeway can change both access and ecology by turning a water crossing into a fixed path. A causeway may make travel easier for residents, visitors, goods, and emergency services. It can also alter currents, sediment movement, fish passage, and the flow of water through bays or marshes. In some places, a road across shallow water reduces the island's feeling of separation, changing work, tourism, housing, and daily routines. In other places, causeways are carefully designed with bridges or openings so water and wildlife can continue moving. The effect depends on local geography and engineering choices. A causeway is more than a strip of built ground. It is a decision about how much connection to create and what kind of movement to preserve. Where water once fully separated two shores, a new line begins to guide both people and tides. Open coastal winds make some islands good places for wind farms, especially where fuel can be expensive to import. Many islands have strong, steady winds because they are exposed to broad stretches of sea. Turbines can turn that moving air into power for homes, harbours, water systems, and small industries. Renewable energy can be especially valuable on islands that have long depended on shipped fuel, which costs money and can be delayed by weather. Wind projects still require careful planning because turbines affect views, birds, bats, noise, maintenance, and local consent. The best designs respect both the landscape and the people who live there. A turning turbine on an island ridge is a modern sign of adaptation. Like sails and wind-bent trees before it, it shows that island life has always paid attention to moving air. Buildings on islands often reveal careful responses to wind, heat, rain, and salt air. In tropical places, houses may use raised floors, wide eaves, shutters, verandas, and open airflow to stay cooler and drier. In colder or stormier islands, walls may be thick, roofs low, and windows small to resist wind and hold warmth. Materials often come from what is nearby: stone, timber, coral blocks, thatch, turf, clay, or imported metal. Salt can corrode fittings, damp can enter walls, and storms can test roofs. So island architecture usually learns from weather over time. A building that looks simple may contain many local decisions. It may face away from prevailing wind, sit above floodwater, or use shade from trees. On an island, shelter is not only about walls. It is a quiet conversation with the climate. Before instant communication, post offices and mailboats made island distance feel organized and dependable. Before instant communication, letters connected island residents with family, government, business, and news beyond the water. In many places, mail arrived by ferry, small boat, airplane, or passing ship, and the timing of delivery became part of local routine. A delayed crossing could mean a delayed message, while a clear day could bring a whole bundle of voices from elsewhere. Stamps and postmarks from islands often became small symbols of place. carrying names across the world on envelopes. The system was practical, but it also had emotional weight. A letter could cross an ocean and end in a hand on a small pier. Island mail reminds us that connection is not only about roads. It can be carried in bags, boats, schedules, and patient waiting. Education on islands has often depended on creative ways to overcome distance. Small island schools may serve only a few children, while students from remote settlements sometimes travel by boat, ferry, or small plane to reach classrooms. Teachers may work with mixed ages in one room, making lessons flexible and personal. In some places, radio, correspondence lessons, and later online tools have helped connect island learners with wider resources. Education on islands can include ordinary subjects, but it may also carry local knowledge about weather, fishing, farming, language, navigation, plants, and community history. A school beside the sea is not cut off from the world. It is linked to it in particular ways. The island setting can make learning feel close to daily life. Lessons may begin indoors, then continue at the shore, the garden, or the harbour. Healthcare on islands faces special challenges because weather and distance affect care. A small island may have a nurse, doctor, clinic, or visiting medical team, but serious treatment may require travel to a larger island or mainland. Ferries, helicopters, small planes, and rescue boats can become part of the health system. Storms or rough seas may delay movement, so planning and local skill are especially important. Clinics often need to manage supplies carefully, from medicines to fuel and clean water. At the same time, island health workers may know their communities closely, with care shaped by long relationships and practical knowledge. The geography adds pressure, but it also reveals commitment. On an island, medicine is not only about buildings and equipment. It is about connection, readiness, and the careful crossing between shores when help is needed. Offshore quarantine stations were often used because surrounding water created a natural layer of separation. In earlier centuries, ships arriving from distant ports could carry diseases, so some governments used islands to inspect passengers, isolate the sick, or hold goods before they reached busy cities. These places might include hospitals, dormitories, disinfection buildings, cemeteries, and docks. The purpose was practical public health, though the experiences of people held there varied widely. The geography mattered because an island could be close enough to manage, but separate enough to reduce contact. Many former quarantine islands are now historic sites, parks, or ruins with quiet buildings facing the water. They show how islands have been used not only for settlement or shelter, but for careful distance. The surrounding sea became part of a human system for protection, fear, waiting, and return. Surrounding water made island forts easier to defend. Across many coasts, people built forts on harbour islands, tidal rocks, and narrow offshore points because attackers had to cross exposed water before reaching the walls. The island position could control a shipping channel, protect a town, guard a prison, or watch over a valuable anchorage. Builders used stone, brick, earthworks, cannons, towers, and later concrete depending on the period and technology. The water acted like a natural moat, but it also created challenges for supplying food, fresh water, ammunition, and repairs. Many old island forts are now quiet ruins or museums, with grass growing over walls once planned for warning and defense. Their history shows how geography can become strategy. A small piece of land may gain importance because of where the sea places it. Remote islands, tidal rocks, and lake islands have often held monasteries where separation supported focus, safety, or devotion. Across different cultures and religions, small islands, tidal rocks, and lake islands have held temples, hermitages, churches, and monastic communities. The surrounding water created a natural boundary, limiting noise and ordinary traffic from the mainland. It could also make the journey there feel meaningful, because reaching the site required a boat, a causeway, or careful timing with the tide. Builders adapted to difficult stone, wind, thin soil, and limited supplies. Some island monasteries became centers of learning, art, manuscript copying, farming, or pilgrimage. Their ruins often appear simple against sea and sky, but they reflect organized communities and long effort. The quiet setting was not empty escape. It was a chosen landscape where daily life, discipline, and belief were shaped by water. Rapa Nui is famous for its moai, the large stone figures carved by its island society. The island, also called Easter Island, lies far out in the southeastern Pacific, making its monumental sculpture especially striking. Most moai were carved from volcanic tuff at a quarry called Rano Raraku, where unfinished figures still remain in the landscape. The statues were part of a complex cultural world, connected to ancestors, authority, and community memory. Their calm faces and long forms have made them recognizable around the globe, but they are not mysterious in the sense of being unknowable. Archaeology, oral traditions, and careful study have helped explain much about how they were made, moved, and used. Rapa Nui reminds us that a remote island can hold artistic ambition on a grand scale. Distance did not limit imagination. Old island ruins can show how people adapted to limited space, weather, and distance. Old stone walls, terraces, wells, paths, harbors, and house foundations often reveal choices shaped by the island itself. Farmers built terraces to hold soil on steep slopes. Fishers placed shelters near landing places where boats could be pulled above storms. Communities stored water, protected crops from wind, and used local stone, wood, turf, or coral depending on what was available. When people left, the structures often weathered slowly under salt air and rain. The ruins may look lonely, but they are full of practical memory. They show how daily life once fitted itself to a small world of shorelines and seasons. An abandoned island settlement is not only a scene of loss, it is evidence of skill, patience, and the effort to live within clear limits. Terraced island farms turn steep slopes into steps that can hold soil and water. On many mountainous islands, flat land is rare, so people have shaped hillsides into narrow levels, supported by stone walls or earth banks. These terraces slow rainfall, reduce erosion, and create small fields where crops can grow. They can be used for rice, vines, vegetables, grains, or fruit trees depending on climate and culture. From a distance, terraces make the island look carefully folded, with human lines following the natural slope. Their upkeep requires steady work, because walls must be repaired and water channels kept clear. The design is practical, but it can also be beautiful. Terraces show that island landscapes are often made by cooperation between land and people. A difficult slope becomes usable not by force, but by patient shaping. Vineyards and orchards on islands often depend on small differences in slope, wind, and sea air. The surrounding water can soften temperature extremes, while hillsides may catch sun or shelter plants from strong winds, volcanic soils, limestone terraces, sandy flats, or stony slopes can all influence how vines and fruit trees grow. In places such as the Mediterranean, Atlantic islands, and parts of the Pacific, people have developed farming methods suited to narrow fields and salty breezes. Low stone walls, windbreaks, and terraces may protect crops from exposure. The harvest from one valley can differ from another only a short distance away, because island microclimates are tightly packed. These farms show that islands do not only limit agriculture, they can refine it, making growers pay close attention to light, moisture, soil, and the direction of the wind. Small islands can have strong local food traditions because people cook with what the land and sea provide. Fish, shellfish, seaweed, coconuts, breadfruit, taro, yams, grains, herbs, or hardy vegetables may become central depending on the region. Limited space can encourage careful use of gardens, seasonal harvests, drying, fermenting, smoking, or salting. Trade and migration add new ingredients, so island food is rarely isolated in a simple way. It often blends local resources with long routes of exchange. A recipe may carry the taste of a reef, a volcanic field, a forest garden, and a visiting ship all at once. Food traditions make island geography intimate because they turn soil, weather, currents, and travel into daily meals. The plate becomes a small map, showing how people have learned to live with their island's gifts and limits. A market on an island often reflects both local limits and wide ocean connections. A market might offer fish caught that morning, fruit from hillside gardens, spices brought by trade, baskets made from palm or reed, and goods carried by ferry or cargo boat. Because islands often have limited farmland or manufacturing space, many items arrive from elsewhere. At the same time, the things grown, gathered, or made locally can be especially distinctive. The market becomes a meeting point between the island's own resources and the larger world beyond the water. Its sounds and smells may carry clues about weather, season, and travel. A poor fishing day, a delayed boat, or a good harvest can change what appears on the stalls. In this way, an island market is a small living map of dependence, adaptation, and exchange. Honey from an island can carry the flavor of a small landscape through the flowers bees visit. Bees gather nectar from plants within flying range of their hives, so on an island, the available blooms may be shaped by coast, cliff, forest, garden, and season in a concentrated way. Heather, thyme, eucalyptus, citrus, palm, wildflowers, or native shrubs can each influence the honey's scent and taste. Some islands value local honey because it reflects plants that grow there and nowhere else. Beekeeping also depends on weather, because wind, rain, drought, and flowering times affect how bees forage. A jar of island honey is not just sweetness. It is a quiet record of many small journeys between flowers. In that golden food, the island's sunlight, soil, wind, and plant life are gathered into something people can hold. Cemeteries and burial grounds can reveal long relationships between island communities and the sea. In many island communities, graves are placed near churches, on hillsides, beside villages, or within sight of the water. The locations reflect faith, family, available land, and the geography of a small place where every usable area matters. Old stones may weather under salt air, and inscriptions can become softened by wind and rain. These spaces are not only about endings. They preserve names, languages, symbols, and evidence of settlement over generations. On islands with histories of migration, fishing, farming, or trade, burial grounds can quietly show where people came from and how communities changed. They also remind us that islands are lived places, not just landscapes. A shore may receive boats and storms, but it also holds memory, care, and belonging. Shell middens are island archives made from the remains of meals and daily life. A midden may contain layers of shells, fish bones, charcoal, tools, pottery, animal bones, and other traces left by people over long periods. On islands, these deposits can help archaeologists understand what people ate, where they gathered food, how sea levels changed, and how communities used nearby reefs, beaches, and forests. A pile of shells may look ordinary, but each layer can hold clues about seasons, trade, cooking, and settlement. Middens are often fragile because waves, erosion, construction, or collecting can damage them. They deserve care as records of human knowledge and adaptation. A shell midden is not just discarded material, it is a quiet library of shore life, written in fragments of food, fire, tools, and time. Stone fish traps use tides to gather food with patient design rather than constant chasing. Around many islands and coastal communities, people built low walls of stone, coral, or wood in shallow water. At high tide, fish swim over or through the trap. As the tide falls, some fish remain inside pools or narrow spaces where they can be collected. These traps require careful knowledge of tides, currents, fish behavior, and local materials. They can last for generations when maintained, becoming part of the shore itself. Their shape may be hard to notice from land, but from above they can appear as arcs, lines, or enclosures written on the reef flat. A fish trap turns the island's tidal rhythm into a form of cooperation. The sea moves in and out, and the structure quietly waits. Stories, songs, place names, and family teaching can preserve practical island knowledge about coasts, currents, seasons, and safe travel. Stories, songs, place names, chants, and family teaching may carry information about reefs, fishing grounds, weather signs, freshwater sources, dangerous passages, or the timing of harvests. This knowledge is not separate from culture. It is often woven into memory, ceremony, navigation, and everyday language. On islands where written maps were once limited or unnecessary, spoken knowledge helped people move through complex seascapes with care. A name for a rock, channel, or wind may hold a warning or a history. These traditions can also record past storms, migrations, eruptions, or changes in the shore. They remind us that an island is known not only by measuring it, it is known by living with it, speaking it aloud, and remembering what the water and land have taught. Across island communities, dialects and languages can preserve older words, while also creating new ones. Separation by water may reduce daily contact with larger populations, allowing speech to develop in its own direction. At the same time, islands often receive sailors, traders, migrants, and visitors, so their languages can also become rich with borrowed words. The result may be a voice shaped by both isolation and connection. Words for winds, currents, boats, fish, landforms, family, and weather can be especially important because they belong to daily life. Some island languages are endangered when younger generations shift to larger national or global languages. Others remain strong through schools, songs, stories, and ordinary conversation. A language carries more than information. On an island, it can hold local knowledge about reefs, seasons, paths, and places that maps may never fully explain. A single island name can preserve layers of language, travel, memory, and observation. A single island may have an indigenous name, a colonial name, a name used by sailors, and a modern official name. Some names describe shape, color, plants, animals, saints, rulers, winds, reefs, or events. Others carry meanings that are no longer obvious without knowledge of the original language. Renaming can reflect power and history, while restoring older names can recognize deeper connections to place. Maps may show one label, but local people may use several names depending on context. This makes island names more than convenient tags. They are small historical records attached to land. When spoken carefully, a name may reveal how people first approached the shore, what they noticed, what they valued, or how they remembered the island across generations. Shore temples and shrines often face the water because the sea is part of daily meaning. In many cultures, sacred places near island coasts are linked to safe voyages, fishing, storms, ancestors, creation stories, or gratitude for the sea's gifts. Their placement may follow old paths, landing places, freshwater springs, cliffs, or views of sunrise and sunset. Some are simple stone markers or small chapels, while others are larger temple complexes shaped by centuries of care. Salt air, wind, and waves slowly weather these buildings, so repair and ritual may become part of the same long relationship. The sea near them is not only scenery, it is the force that brings food, danger, visitors, and memory. A shore shrine shows how island people often turn geography into reverence, giving the water a place in human attention. Festivals on islands often follow the rhythm of fishing, harvest, saints' days, seasons, or returning boats. Because island communities are shaped by distance and shared resources, gatherings can carry special importance. A festival may bless a fishing fleet, mark the start of a harvest, remember ancestors, celebrate music and dance, or welcome visitors from nearby islands. Food, boats, costumes, songs, and local crafts can all reflect the surrounding sea and land. These events are not separate from geography. They often happen when weather allows travel, when crops are ready, or when fish follow their seasonal patterns. On a small island, a celebration can bring nearly everyone into the same public space. The festival becomes a living bridge between ordinary work and shared memory. It shows that islands are not only quiet landscapes, but communities with calendars, voices, and recurring joy. Small museums on islands often protect objects that reveal wide ocean histories. A fishing hook, carved paddle, shell necklace, glass bottle, woven mat, ship bell, or weathered photograph may tell a story larger than its size. On islands, objects often carry evidence of travel, trade, migration, storms, work, and adaptation. A tool may show how people used local shell or bone when metal was rare. A map may show old routes between harbors. A piece of pottery may reveal contact with another shore. These collections matter because island histories can be scattered by weather, distance, and changing settlement. A museum gives fragile things a stable room, away from salt air and rain. It helps visitors see that an island is not simply scenery. It is made of memory, skill, exchange, and ordinary objects that survived long enough to speak. From far away, an island map may look simple, but the shore can become complicated in detail. A smooth outline on a small map may hide bays, reefs, cliffs, sand spits, tidal flats, marshes, caves, and tiny offshore rocks. Cartographers must decide how much detail to show, depending on the map's purpose and scale. For sailors, a reef or channel can matter more than the inland shape of a hill. For walkers, a path, spring, or pass may be more important. Islands also change, so maps can become outdated where storms, erosion, volcanic activity, or shifting sand alter the coast. The map is useful, but it is never the whole island. It is a careful simplification of a place where land and water meet in many small ways. The real shore is always richer than its outline. Clouds can sometimes reveal hidden islands to sailors before the land itself appears. Over some islands, warm air rises from hills or forests and helps form clouds that sit or gather above the unseen shore. Navigators in different ocean traditions watched for such signs, along with bird flight, wave patterns, and changes in light. A cloud that remains steady while other clouds drift may hint at an island below the horizon. The clue is not perfect, because weather can mislead, but it has been part of careful sea knowledge for a long time. Islands do not always announce themselves first as dark shapes on the water. Sometimes they appear as a change in the sky. The land lifts air, the air forms cloud, and the cloud becomes a pale signal for those who know how to read it. With little artificial light and a wide ocean horizon, island night skies can be especially clear. Far from large cities, the darkness over an island may reveal the Milky Way, bright planets, and many faint stars that are harder to see from populated mainlands. The surrounding sea can make the horizon feel open, giving the sky a broad, rounded presence. Clouds, mist, and humidity still matter, so not every island night is clear. Yet remote islands have often been important places for astronomy, navigation, and simple stargazing because they offer distance from light pollution. For ocean travelers, stars were once part of the map. For island residents, the sky could mark seasons, directions, and stories. At night, an island may feel less alone than it did by day, held beneath a wider field of light. Fireflies and glowworms can make island forests and cliffs appear softly lit by living signals. These lights are produced by chemical reactions inside the bodies of insects or their relatives, and they are usually used to attract mates, lure prey, or communicate. On some islands, damp forests, caves, riverbanks, or old fields create suitable conditions for these tiny displays. The glow may appear as brief flashes among trees or as steady points along a sheltered wall. Because such species often depend on darkness, artificial light kibats can interfere with their signals. Their presence reminds us that an island's nightlife is not limited to stars and waves. Some of its quietest lights come from small creatures close to the ground. A path through the dark can become a map of signals, each glow serving a purpose. Complete silence is rare on an island because small sounds travel clearly across open water and quiet land. Waves repeat against rocks, leaves move in wind, seabirds call from cliffs, insects hum in grass, and boats may be heard from far away. At night, water can carry sound between shores, making a distant engine or bell seem closer than it is. This soundscape changes with weather. Fog can soften the world, strong wind can fill every gap, and calm air can make even gentle movements noticeable. On a small island, the ear learns the shape of the place as much as the eye does. Sounds mark the tide, the harbour, the nesting colony, the trees, and the weather coming in. An island is therefore not just a view surrounded by water. It is a quiet arrangement of repeating voices, across valleys, shores, and villages where roads were few. Bells and drums once carried messages. Sound travels differently in open coastal air, across water and between steep slopes, so communities often use clear signals for warning, gathering, ceremony, or work. Church bells, conch shells, wooden drums, gongs, and other instruments have all served as practical voices in island settings. A signal could announce a boat, mark time, call people to worship, or share news faster than a messenger walking a rugged path. These sounds belong to the geography around them. Cliffs could reflect them, forests could soften them, and wind could carry or scatter them. The idea is simple and vivid. An island does not communicate only through roads and harbours. It can have an acoustic map shaped by distance, weather, and the need to be heard. People can build new land, but artificial islands require constant engineering to remain stable. Some are made by piling sand, rock, concrete, or dredged sediment in shallow water, while others grow from older reefs, breakwaters, or harbour works. They may support airports, ports, homes, roads, resorts, or protective structures. Unlike many natural islands, artificial islands depend heavily on planning, maintenance, and defences against waves, currents, settlement, and storms. Engineers must think about foundations, drainage, erosion, and the effect on nearby marine life. The idea of making land can seem simple from above, but water keeps testing the edges. An artificial island is a reminder that surrounding water is never passive. It presses, moves, carries sediment, and searches for weakness. Built islands may look fixed, yet they remain in negotiation with the sea around them. Floating mats of vegetation can become natural islands on lakes, marshes, and slow rivers. These mats form when roots, reeds, peat, and plant debris weave together into a buoyant surface that can support grasses, shrubs, insects, birds, and sometimes small animals. They may be anchored at the edges, or they may drift with wind and current. In some wetlands, floating islands help clean water by absorbing nutrients and giving microorganisms a place to live. Their surfaces can look like ordinary ground, but below them is a soft, living raft resting on water. People have even built artificial floating gardens in some regions, using the same basic idea of plant matter, buoyancy, and careful tending. A floating island reminds us that islandness is not always hard rock or sand. Sometimes it is roots holding together a quiet patch of green above a hidden depth. And so, our quiet journey across the world of islands comes to its close. We have drifted from reefs and lagoons to cloud forests, nesting cliffs, hidden caves, old harbours, island languages, migrating birds, and shorelines shaped by wind, salt, and time. Each island has shown us something slightly different. Some rise from fire, some are built by coral, some are carved by rivers, ice, or waves, and some are held together by roots, sand, and patient life. What makes islands so fascinating is not only their separation, but the many kinds of connection they keep. The sea can isolate them, but it also carries seeds, boats, birds, clouds, stories, and memory. A small shore can be part of a vast ocean system. A quiet forest can depend on bats, crabs, rain, fog, and seabirds. A single harbour can hold generations of arrival and return. Places do not need to be large to be complete. They can be small and still contain deep history, careful adaptation, and entire worlds of life. Their edges may shift, Their weather may change, and their species may be fragile, but they remain among the clearest examples of how land, water, and time work together. For now, let those island shores grow distant and soft in your mind. Let the tide move gently in the dark. Let the last image be simple: a quiet island beneath a wide sky, surrounded by calm water, holding its small world through the night. Sleep well. Good night.